In this video, we'll be looking at the long division of a two-digit dividend by a single-digit divisor. Let's start by looking at a solved example. We can see here that 66 divided by 3 is equal to 22. So what exactly does this answer mean? 3 fits into 66 22 times. Or, if we separate 66 into 3 equal groups, each group will have exactly 22 elements. Recalling that multiplication is the inverse function of division, we can also look at the divisor and the quotient and see that 3 times 22 is equal to 66. Let's look at another example. Here we see that 68 divided by 3 is equal to 22 with a remainder of 2. What does this answer mean? Well, because there's a remainder, we can see that 3 does not fit into the dividend evenly. Instead, we see that 3 fits into 68 evenly 22 times, with 2 elements of the dividend left over. Or, if we separate 68 into 3 equal groups, each group will have 22 elements with 2 elements of the dividend left over. In other words, if we take 2 away from 68, then 3 fits cleanly into the difference. So as before, recalling the inverse relationship between multiplication and division, we can see that 3 times 22 is equal to 66. Now, if we add our remainder, 2, we will have 3 times 22 plus 2 is equal to 66 plus 2, which equals 68. So that's what's happening in the general division algorithm. First, we find the largest multiple of 10, for which the divisor times that multiple is less than the dividend. For example, if we take 68 divided by 3, we know that 3 times 20 is equal to 60, which is still contained within the dividend. For the second step, we then subtract that product from the dividend and determine the largest multiple of 1, for which the divisor times that multiple is less than the difference. And we'll subtract that value from the dividend as well. So we take 68 minus 60, which leaves us with 8. We now know that 3 times 2, which equals 6, is the largest multiple of 1, which is still contained within 8. So 8 minus 6 is equal to 2. The total number of multiples that you calculated in steps 1 and 2 gives you the total number of times the divisor will fit into the dividend evenly. So here we calculated 20 and 2 multiples, which gives us 22 whole multiples. Now for the third step, what remains is an integer which doesn't contain any whole copies of the divisor. So this becomes the remainder. For more information about what to do with the remainder, refer to the single-digit division videos or the fraction to decimal conversion video. With this algorithm, it's relatively easy to see the inverse relationship between multiplication and division. When a divisor can be evenly multiplied into the dividend, it's clear that the quotient times the divisor will equal the dividend. Let's look at an easier example. If we have 56 divided by 4, we will find that this cleanly divides to 14. Here, it is easy to look at the divisor and the quotient and see that 4 times 14 is equal to 56. It should be noted that division problems don't necessarily need to be completed vertically. That's just a convention we use for easy bookkeeping. They can be done just as easily and correctly in a horizontal format using the same algorithm. For example, if we have 82 divided by 5, we will find that 5 times 10, which equals 50, is the largest multiple of 10 that is contained within the dividend. So taking this difference, we have 82 minus 50 is equal to 32. Now, looking at this difference, 32, we will find that 5 times 6, which equals 30, is the largest multiple of 1, which multiplied by 5 is still contained within the difference. So taking the difference, we have 32 minus 30 is equal to 2. This gives us our remainder. So adding together the number of multiples of the divisor in each step, we will see that 10 multiples plus 6 multiples plus our remainder of 2 gives us 16 remainder 2. This is our quotient.